Welcome to Weather Questions, where we answer the questions on your radar.
Welcome in, everybody, and thanks so much for joining us here. This is episode 4 of the Weathered Questions podcast, and we do want to remind you this is all about educational, digestible, and relatable questions that you might have on your mind, and we're happy to answer them in a very simple and non-complex way. We do want to know what's on your radar. Get it? What's on your radar? Email us your questions to weatheredquestions@gmail.com to join on in the conversation. My name is Kaj O'Mara, Jan Ryherd alongside me.
Hi, everyone.
Going into the 4th episode already, Jan. It's been fun.
It has been fun. We're figuring it out. Thanks for, sticking with us here as we continue to get things under our belt. We've been out of broadcast for a little bit, so still checking all the boxes, making sure we have everything ready to go. But we're having some fun with this, and we're glad you're along for the ride.
Definitely. Speaking of broadcast, back when I first started in 2007, there just wasn't a whole lot of social media to go around. We had Facebook for college kids mainly is where it was. And when we went on the air to cover tornado events and severe thunderstorm events, we didn't have many visuals. And whatever visuals we had were generally emailed to us after the fact. We got very little during coverage itself. And now as media continues to grow, whether it's YouTube or whether it's TikTok or wherever we're getting some of the media from, we get all sorts of pictures. And we have seen pictures, even this year, of various places where people have sheltered during times of tornado warnings. And I had an opportunity back in late May. I was down at the school district here just south of me. And a teacher managed to get a question, and the kids were asking all sorts of questions. But I finally called on a teacher just to see what she wanted to say about the whole thing. And one of her questions was, is it really safe to shelter under an overpass in a tornado? I've got my thoughts on this. Jan, why don't you start us off, and then we'll get this topic going here today.
Yeah, a common question. I've been asked that in several school visits by the kids. What do we do if we're outside? Where can we go? And a lot of people do think that you should get under an overpass. And sometimes that's because you want to protect your car from hail. Sometimes it's because you're just looking for a place to shelter because the winds are picking up or you're in a tornado warning. But actually, what a lot of people don't realize is that an overpass, or those bridges that are between two intersecting highways or something like that, that is actually one of the worst possible places that you can shelter. And again, it seems counterintuitive because you would think, okay, great, my car is protected, it's under something. But what actually happens is that the overpass kind of funnels the wind into one channel, and it acts basically as a wind tunnel. And so what happens, and they've actually done studies on this with anemometers and things that can measure the wind speed, it actually is faster. The wind speed is faster under an overpass than it is out in the wide open because of that wind tunnel effect that is created. So it is actually a pretty dangerous sheltering location, and you're actually better off kind of preferably you haven't put yourself in that situation. Preferably you've been paying attention to the weather and that there's a potential and you have the chance to get to a safe shelter, like a sturdy structure, a sturdy building. But if you are caught outside in a car, you're actually much better off getting into a lower lying area like a ditch or something like that.
Fully agree on all accounts here, Jan. And again, this is one of those questions where it might be a hypothetical situation where hopefully you don't ever find yourself someday. And it might be one of those, if I'm in a jam, I've got to take cover somewhere. And, we do want to say that this is just general guidance. In no way is this something we'd advocate doing. Sometimes it has to be done if it's an absolute emergency, but we really want you to try and avoid that for the reasons that Jan just said. But the other thing about this is think about, have you ever had your car broken down on the shoulder, like a flat tire or something was going on? Maybe you had a really fussy kid or something, been there, but we didn't pull off on the interstate to fix the issue. We got an exit ramp and got off the road. But, It's not just common courtesy, but in some cases it's the law to move over when somebody's on the shoulder. And if you're wondering where I'm going with this, if you're pulled off under an overpass and we've got blinding rain going on, people can't see where they're going. And there's a chance of hydroplaning. There's a chance of reduced visibility. And all of a sudden they get by that overpass and there's a car right there. You might even cause an accident. And that's the last thing you want to do. Or bottleneck traffic. That's a problem. And so I've always generally given the advice to anybody who asks that question is, and this comes straight from my dad, he always said, know your escape route. If something is happening in front of you, when's your next exit? If you have to get off the road, when is that next exit? Because almost always it's going to be in an interstate situation, but maybe a highway situation. And to your point, if you're on a highway, you may not have too many bridges on highways. And so at that point, you may seek shelter in a ditch and let the storm pass. And so there's so many different options for so many different scenarios that could occur to you. All we know is that largely this is a non-safe option. But of course, if it comes down to life-saving versus non-life-saving, you've got to do what you got to do. I would just try and avoid that. I think trying to avoid that's going to be safer for everybody involved, Jan.
Yeah, absolutely. Well, hopefully that answered your question. If not, remember, you can always submit a follow-up or additional question if that sparked more to the Gmail, weatheredquestions@gmail.com. All right, let's head on into trivia for this week. This one kind of sparked off of last week's conversation a little bit where we got into lightning. And it made me think, I wonder if people know, how far away can lightning strike from its parent thunderstorms? That where that lightning is originating from. How far away can lightning strike? We're not going to give you any answer options on this one. It's going to be a range, but we'll let you kind of ponder that for a little bit, and we'll hear a message from our sponsors.
Picture this, a maintenance-free deck paired with a jaw-dropping pergola, giving the perfect blend of shade and style and making the ideal spot for relaxing and enjoying the outdoors. Now imagine a sunroom, a bright, inviting space where nature can be enjoyed year-round from the comfort of your home. At Hometown Restyling, big dreams become reality, and it's easier than ever with 0% financing for 60 months. Go to hometownrestyling.com for a free quote.
Today's trivia question.
All right, back to the answer for today's trivia question. A reminder, that question was, how far away can lightning strike from its parent thunderstorm? And the answer for that one is 10 to 15 miles. Generally about 15 miles. Sometimes it can go a little bit higher than that. It could be as wide as that, up to 20 mile per hour range or 20 mile range. But yeah, 15 miles. Think about that. You could have blue skies overhead and still get a lightning strike nearby. So we like to say that if you can hear that thunder, it means that lightning is close enough and that you need to be getting to that safe shelter as soon as possible, because it could still create an issue if you are close enough to hear that thunder, whether or not you have clouds overhead.
You mentioned blue sky. There's actually a term for that called bolt from the blue.
Mm-hmm.
And there are stories of that happening. And these lightning bolts can arc many miles, as you just said, from the cloud base. Though secretly, I was sitting here in my chair thinking, we really need the Jeopardy theme today. Of all the times, it was a write-in question. What is 10 to 15 miles? We would have had a winner. It would have been fun. But this is one of those things
Do you think we can get rights to that, Kai?
No.
Oh, darn.
So that's why it was in my head, not in the actual podcast.
Maybe someone will submit their own version of it for us to use. That'd be cool.
I can have my daughter play it on the piano.
There you go.
Then it's original content.
All right.
And you can't touch it.
Sold.
That's going to be her assignment. That'll be her assignment and maybe her goal. We'll see if we can get it recorded and on tape, and we can use that for trivia going forward. But when it comes to lightning and radius, I'll tell you, a lot of outdoor sports have rules about that. The bolt needs to be 7 miles away. It needs to be 10 miles away. Anything closer than that, suspend play. Anything, and the thing about it is it does vary a little bit with whatever ball club you're talking about or whatever rule package they're using. But lightning is so fast and it is so fickle sometimes. And when you start to see a trend happening, or, okay, that bolt is 7 miles away. Great. Well, it's 7 miles for right now. But when that storm moves 4 miles closer to you, are you telling me you're not going to suspend play because we haven't had a strike yet? Probably not. So that's where the whole topic of lightning detectors can come in, which is a whole different show in and of itself. But it's really important. It's really important. And that was a good carryover, I think, Jan, from last week's topic on lightning, because this is our peak lightning time. Summer is peak lightning time in the Midwest, and a lot of outdoor events, county fairs are getting going now too, being at the end of June like this. And so it's just something that's really good to think about, I think, as we do move forward here.
Yeah. And to kind of mold that topic as well as our original topic of, sheltering under an overpass, right? Something you don't want to do. As you're, have those fairs that you're going to, those outdoor events, those sporting events, keep in mind where you would shelter if something kind of turned up kind of quickly. Again, hopefully you're paying attention to the weather and if that potential is there and you're not putting yourself into a bad situation. But hey, we get it. Things happen. You're out there supporting your kids through thick and thin. And we want to make sure that you have that safety top of mind as well. So know if there was lightning and you needed to get to shelter quickly, where that kind of spot would be nearby, and make sure it's not under a tree, because that is absolutely not where you want to be. You want to be inside in a safe, sturdy shelter.
What's your escape route? That's what my dad always says.
Yep.
What's your escape route? And it is not just to wherever you're driving. There are other avenues of life that you can use that analogy to think about things. Okay, so we're in the summer months now. We're going to start getting hotter in the next several weeks. And peak heat in the Midwest really isn't for another month yet. It's mid to late July typically. And so the ground can really start to cook, and it can start drying out very quickly. And I do notice that the TV stations in the area are showing this quite frequently, and I do think it's important. It's called the drought monitor. And what happens is all of a sudden you're watching a weather report, or you might be on a website of a local television station, or maybe you're just in agriculture and you're just curious, and all of a sudden your county wasn't yellow last week and now it's yellow this week, or it was red last week and now it's an even darker red this week. So we do want to bring up the topic of what is the drought monitor, Jan, and how do we kind of do it? You want to go ahead and start with this one, and then I can add in a few accents here as we get going.
Yeah, there's so much that goes into this, and folks across Iowa, you've seen this, it. Folks across the grain belt, the corn belt, the heart of the country where agriculture really does drive a lot of stuff, have definitely seen this before. And it's a pretty important thing that we talk about throughout these months. But it maybe isn't what you think it is. First and foremost, the drought monitor is past conditions. It's taking into account where we are, or even technically where we were a couple days ago. It's not a forecast at all. It's taking into account what is happening or has just happened. And the reason I point that out is because a lot of people think, well, it's, all right, we're at a deficit of, let's say, a foot of rain. We need another foot of rain and then we're good. We're even. Not quite, not so lucky. What the drought monitor is actually taking into account is several different parameters. So it does take into account precipitation. However, in addition to all of that, it takes into account things like the temperature, right? How quick are we going to continue to dry out? If we are having excessive heat, that drought monitor is going to show up worse because things are drying out more so. It takes into account soil moisture, vegetation health, something called stream flow, and the reservoir levels, if you have those where you are. So basically talking about how much water is moving around in those rivers and creeks and those water sources around you. So it takes into account all these different things and puts them all together into a map that our state climatologists will actually help put together, along with help from extension officials and farmers who volunteer and help submit soil samples and things like that. So there is a lot of science and a lot of research and stuff that goes into this, and it is a big effort that is kind of a big, team effort, really, because it's not just, okay, we've got 99 counties in Iowa and everyone's submitting one and the state climatologist makes it. Well, but then we obviously have other states that border us. And so our state climatologist is talking with other states and seeing what they are doing and, making those maps look nice and cohesive across the board, and also helping kind of share that data where maybe they have something that isn't quite as intensive in terms of having that data. And so again, a lot of different things that all kind of go together and lump in, but it is so much more than just plain and simple, well, we got 2 inches of rain this week, we're going to see it improve. Maybe, but maybe not as drastically as you might think.
Yeah, not a linear one-to-one relationship either, by the exact things that you just mentioned. And you can just tell by the length of this conversation that it is not a one-to-one. There are so many other factors that go into this. But one thing I can tell you about drought, and it's the only thing I'm going to add on to this, is it is not exciting. Droughts aren't exciting. They don't lead world news. They don't lead local news. Nothing's blowing up. Nothing's on fire. Nobody's boat sank. No tires are getting ripped off cars. It is an extremely slow moving hazard. So what happens is, naturally, people tend to underestimate the damage it can do. It can do billions of dollars of damage. It absolutely can, depending on the severity and depending on what part of the country it affects. But the losses from the drought can be just as substantial as tornadoes, other disasters, and hurricanes. So especially in the agricultural sectors, but it is not just that one-to-one relationship here. And it can take months sometimes for these things to really set in. But there's also something called a flash drought. And even a flash drought, which is relatively fast, a 2, 3, 4 week span of 85, 90 degree temperatures and no rain, all of a sudden people's yards will go brown, things will start to turn, and all of a sudden you find yourself in a drought in just 3 or 4 weeks. Whereas maybe it took 3 or 4 months several years ago to get into that same level of drought. So to your point, it takes temperatures into effect. But again, it's a very slow moving hazard overall. It's not like it's in and out in an hour like severe weather typically is. It lasts a long time, and it's tough to break. Mm-hmm. It typically doesn't break overnight. So it sticks around for a long time. And as you might expect, Jan, with a drought, it takes precipitation to break the drought. And so when we have that kind of stuff, we're looking not just in the short term, but also in the long term. And to tie drought into a long range situation, even the Climate Prediction Center that is run by NOAA does put out drought outlooks, both for relief of drought as well as when we might expect them. So that's a totally separate thing from the drought monitor. But again, so many agencies all working together to try and figure this puzzle out just to help everybody.
Absolutely. Yeah, we've got a lot of excellent resources at our disposal as meteorologists and as public, right? A lot of those, they're public resources. And we're happy to be able to help kind of explain those for you here. So on that topic, since we're talking about breaking that drought, hopefully, why don't we talk about rain and what goes into when you're looking at your weather app or you're watching a local weather forecast on the news, what goes into that percentage chance of rain? We call them POPs affectionately in the weather world, or percentage of precipitation. But how do you determine that percentage chance of rain? It's something that I think we've all been asked ad nauseum, Kai.
Well, this just depends how many hours do we have to talk about this topic. So if you're listening to us maybe on an airline flight, we could go and go and go and go and go about this. But I will tell you that my general rule when I was at the station, there were 2 different percentages that I would never use. I would never use 10% because I felt it was too low. And I would never use 50% because I felt that it fell into that stereotype that a lot of folks thought, well, we're half right, half wrong. So let's not illustrate that, even though some days it felt that way. But the bottom line is, here's a real simple answer. And then we can go into some of the scenarios. The real simple answer is the higher the percentage number, the higher the probability of precipitation happening at your location at a given time. One thing that I will say right off the bat, and I think a lot of folks get this confused, neighbors, I'm not picking on you. I'm not picking on you, but you asked me this question at the final week of school, and we had a 95% chance of precipitation. And that does not mean 95% of the day will be wet. That's not what that means. It may shower for 3 seconds. 3 seconds. And that's all you need to verify it if it measures up. It's got to measure up. It has to measure up to 1/100th of an inch to verify a rain chance. So let's get that out of the way right away. That a high percentage chance of rain does not mean the whole day will be wet. Similarly, if it's a very low percentage, it doesn't mean that it's just going to be a small fraction of the day. It might, get out of hand and expand in coverage. And all of a sudden we have a higher chance on our hands. But at its very core, we're talking about probability. And it's the exact same unit that we all went through in elementary school and intermediate school and middle school, the probability of precipitation happening. And so one thing I like to do is you can split this up into 2 camps. You could say, what is my probability in my individual location? That's one way to think about it. If it's 50%, just because it's easy math, I have a 1 out of 2 chance that day at my house of getting rain. And if probability comes true for every single individual in the viewing area or in the coverage area, then yes, 50% of the area, in theory, will also get rainfall. And so I don't think it's bad to also think about it in that context if it's easier for you. Just don't confuse it with that much of the day is going to be wet. But I want to run an example by you. So when I would go to career talks or when I would go to school talks that were generally 6th grade and up, we would not do this with K through 4, K through 5. They were more interested in pretty pictures and clouds and storms and things like that. But as the kids were a little more advanced and knew a little bit about math, we'd run a simulation in the class. And I would bring a quarter with me. And I'd say, all right, heads or tails. And if there's 30 kids in the class, let's run this experiment. And so obviously with heads and tails, a coin's not going to land on its side, right? So heads, 50%, tails, 50%. There's a 50% chance of rain 50% chance that every student is going to get rain, right? Mm-hmm. And you go through with 30 kids. And at the end of the run, I had 16 heads and 14 tails. So what that means is it was actually slightly skewed more towards the heads. So from an area standpoint, it was actually higher than 50%. But from an individual point standpoint, it was exactly a 50% chance at every student's desk. So if probability comes out perfect, then yes, you can interchange the two from a point percentage to an area percentage. But in my case, in that classroom, the area did not come out perfect. It was a 16-14 split. If it was perfect, it would have been 15-15. So despite a 50% chance of rain, we actually wound up with more rain occurrences than not. It's going to be close, typically, but that's a great way, I think, Jan, to break things down into a very easy to digest situation. And you can do this at your own house. If you see a 40% chance of rain, get 4 pieces of paper and cut them up into various shapes, sizes, whatever, and shade, 4 of them red, and then make 6 others white. And draw them in a hat and draw it 100 times and see what you get. I bet you don't get 40. You might get 46. You might get 35. But that's how this works. So I hope that helps kind of clarify that.
I love that example. I think that's a great, really tangible way to think about it because it's true, right? Like we're running simulations and it's basically the probability and the statistics at the end of the day is what we're sharing. But maybe that doesn't always compute super well to that general audience. So I think that's a great way to explain it. But ultimately what it is, if you have a 70% chance of rain, 7 times out of 10 under the exact same circumstances, you will get rain. 3 times out of 10, you will not. If you have a 20% chance of rain, 2 times out of 10 under the exact same conditions, you'll get rain. 8 times you won't. So that doesn't mean, it's not going to rain when you have a 20% chance of rain. It means no, it could still rain. Again, 20%. Like that percentage is there for a reason. It's not a case of below 50 it won't and above 50 it will. We're giving that percentage for a reason. There is actual science and mathematics behind that percentage. So Hopefully that helps make a little bit more sense of what can be a bit more of a confusing topic. And I'm sure something that we'll revisit here before too long, because it is something that we're asked about a lot. So if you still have questions on that, feel free to send those in. A reminder, weatheredquestions@gmail.com to join the conversation. Send us an email, send us your recorded questions as well. We'd be happy to play those here on air and get your questions answered. Thanks for joining us this week. We hope you'll join us again soon. Until then, stay safe.